Hello everyone, I'm Shubhayan Sahu and I'm a PhD student at the University of Maryland, and today we are going to demonstrate an experiment on Galileo's pendulum. So by this time you would already be familiar with how simple pendula work. So simple pendula is just a heavy mass which is hanging from the string, and if I leave it at some height, it will start oscillating and it will come up to the same height here, and it will keep going. So let's just see how that works. So this is how the simple pendulum works, but in this apparatus, what we have here is we have this shaft, which is at 25 centimeters above the level of the board here, and which would impede the motion of the pendula if I leave it now. So it will get stuck here. So what I'm going to do in this experiment is I'm going to leave the pendulum from at 20 centimeters above the table, and I let it go. And so as it moves, it will get impeded by this. So the question here that we're trying to address is that once the pendulum hits this peg, will it come up to the same height that we released it from or not? So do you think it will go up higher, or do you think it will not go as high? So take a moment to think in your head what is going to happen. Let's see what happens. So was your prediction right? Let's look at it again. So we are releasing it from 20 centimeters. And as you can see, it's coming to 20 centimeter above again, even after it hits the peg. So the explanation for this experiment is that during the course of the experiment, the energy of the pendulum is conserved. So when I release the pendulum from this point, it's at rest, so it has no kinetic energy, but it has potential energy because of gravity. But when I release it, as it goes down, it gathers speed, so the potential energy is converted to kinetic energy. And even though it hits this peg, that energy is not going anywhere, so it has to come up to the same height for that kinetic energy to get reconverted back to potential energy. And as you know that in the simple pendulum, the period depends only on the length of the pendulum. As the pendulum hits this peg, it has to oscillate with this shorter length instead of this longer length. So its period will become faster. Let's see that again. So as you see, after it hits the peg, the period becomes faster. It oscillates faster here. But it has to come up to the same height because of conservation of energy. So yeah, that's the simple explanation of this experiment.